Hey, welcome back everyone. So in today's project, we are building a fully automated CI/CD pipeline that deploys a FastAPI application to an AWS EC2 instance using GitHub Actions and Docker. So this is a complete DevOps workflow from code push to production deployment, fully automated. My name is Ashish, and in this series, I'll break down DevOps concepts with practical, real-world projects that anyone can follow and implement. Right? So, before we jump into automation, let us first understand what real problem that we are solving, because this is something that every company struggles with, right? So generally, when an application development takes place, it goes through four steps. So as I have shared over here, so the developer writes the code, then the written code is sent down to the operation team who does further reviews, and the operation team manually deploys it, and then the application runs on production. Again, we are not sure that whether the application would run or not. So this is, I'm talking about pre-DevOps era. So what was the problem? Traditionally, whenever you update an application, even for a single line of code, you have to follow a long list of manual steps. So for example, like SSH into the EC2 server, then pull the latest version of the code, then you need to reinstall dependencies, rebuild Docker image, stop the existing container, start the new container, test the application, hoping that nothing breaks. So this workflow is slow, repetitive, and error prone. High chances that we may encounter into an error. So what is the solution to this particular problem? So we are solving the problem of manual deployment by deploying a completely automated workflow using a CI/CD pipeline. So what happens whenever, so here in this what happens, so whenever we push the code into the GitHub, the code is automatically packaged and the Docker image is automatically built. The images is automatically pushed into the Docker Hub. GitHub Actions automatically logs into the EC2 server. EC2 automatically pulls the latest image. The old container stops, a new container starts with the updated version, and the application become instantly available to users. So earlier, where there was manual intervention in each and every step, now here there is no human intervention. Everything is automated using the CI/CD pipeline. So this is a pretty exciting project, and let us understand the architecture, what we are going to do. So here in our local system or in our laptop, we are going to develop the application, local development of application. Then the developed application, the source code is what we are going to push it into the GitHub repository, right? So it acts as a version control also for us. Then as soon as the code gets pushed into the the repository, the GitHub repository, GitHub Actions pipeline gets triggered. So here all the scripting has been done, and automatically it builds a Docker image. Then that Docker image, when built, is automatically pushed into the Docker Hub, and the image that is stored into the Docker Hub, gets pulled by the AWS EC2 instance that we create, and then that particular image is pulled and that particular image is converted into a container, and then the container is running, and then we access the application using the public IP of our EC2 instance. Simple. So the next time, even if we have a small change in code, for example, what happens now? For example, the developer writes the code, push it to the Git, then GitHub Actions comes into picture, and GitHub Actions create the image, push it to Docker Hub, and then from Docker Hub there is an EC2 instance that pulls the image from the Docker Hub, and then creates a container and then run the image. So now, for example, let's say if the developer makes some changes in the code and pushes it to the GitHub, this entire process is again automated. The developer only has to push the code and rest everything will be automated. So this is what we are going to implement. Great. So now you have an idea. So we will be executing this particular project in four phases. So in phase one, we are going to launch an EC2 instance, install Docker, and we have to make sure that this particular instance is, good enough to, pull the Docker image and then run it as a container so that we can access it over the internet. So in phase two, we are going to do the development task. So here we are going to do the development task. We are going to create the fast API application over here. And important catch is we are not going to install Python or any dependencies here. Everything will be containerized over here as well. So right from the very beginning, we are going to containerize everything. Moving down to phase 3, we are going to make some Git level configuration. So we are going to install Git, initialize Git, and then we are going to push the code into our GitHub repository. And then from GitHub repository, we are going to configure a GitHub action workflow, which upon sensing commit to the main branch will trigger the entire pipeline. And then in phase 4, we are going to create a Docker Hub repository. We are going to store secrets in there because we are not going to put in our credentials and that PEM file details and all into the code. So we are going to set up secrets inside the GitHub repository, and when the pipeline gets triggered, so the secrets will be fetched, and then the we can deploy, and the application will be deployed on the EC2 instance, and we can access it using the public IP. Great. So now let us start with the phase 1, which is the launching of the EC2 instance. So quickly we'll go to our AWS console. So we'll just type AWS console, and what we are going to do, we are going to sign into the console. We are going to use the root user. So my root user is sheesh. Okay, this is my root user. I'll go next. You're going to put my password. It is going to ask my authentication, which I've authenticated. Perfect. So I've logged into my EC2 console. I'll quickly go into the EC2 instance and I'll check for any running instance. So let me go to the dashboard and check whether there is any instance that is currently running. No instance is running. We'll quickly launch one. So let me put down my EC2 instance name as FastAPI CI CD. That's it, right? We'll keep everything default. We'll use Amazon Linux as the image. Then we'll take T2 micro as the instance type. We'll create a key pair. Let me see if I have one. Okay, I have an old one. Let me delete this for you. And then what we are going to do, we are going to create a key pair, create a new key pair. So we are going to name as Fast API CI CD. Fast API CI CD dash, let us put it Fast API CI CD app. Okay, now we'll create a key pair. So this key pair has been created. Let me see, where is it? Okay, this has been created here. Now let me put it in the desktop. Okay, so this key pair has been created. Perfect. Now what you are going to do? Okay, so key pair has been created, and now meanwhile what we are going to do? We are going to launch the instance. So instance will take a while to launch. I'll put the terminal over here. Okay, perfect. So the instance has been successfully launched. Let us see the state of the instance. It is still in pending state. Let us refresh. It may take a while. Okay, perfect. So it is in running state, right? Now what you have to do, we have to connect our local system to this EC2 instance. So what you're going to do, you're going to use our terminal. And let us see, where are we now? First, let us go to desktop. Okay, I think we are at desktop now. Okay, if we see our key file ls-lart, so our key file is over here, and do you see the PEM file over here? But this PEM file has currently got the read and write permission, so anybody can come down and modify this particular file and compromise our EC2 instance server. So what we are going to do, we are going to change the permissions. So we'll use chmod and we'll do 400 permission on to what our file fastapi.pem. Now if we run the same command, let us see. Okay, so now it only has the read permission. Perfect. Now what we are going to do, we are going to SSH into our system. So SSH-i, then our file, that PEM file, that is fastapi.pem. What is our user? Our user is ec2-user @ public IP. So public IP is what we'll be getting from the dashboard. So we have copied the public IP, we have pasted over here, and let's see whether we get allowed. Okay, yes, perfect. So we have launched into our EC2 instance. Now what we are going to do, we are going to update the existing package and repositories. So what we are going to do, we are going to use sudo yum update hyphen y. So this will update all the existing packages and repositories, whatever it is required. So it is going to update those. It may take a while. Okay, done. So let us check if this Docker is installed or not. So Docker hyphen hyphen version. So Docker is not installable. So what are we going to do? We are going to quickly install Docker. So it is sudo yum. Yum is the package manager. Install hyphen y Docker. So it is installing Docker over here. This may take a while. So generally why we are installing Docker on our EC2 instance, as I said that we are not going to manually install the dependencies on our local system on our EC2 instance. Each and every task, whatever we are going to perform, it is going to be containerized. And to containerize our application onto our local system and onto our EC2, instance, that is our production server. So we need Docker installed. We need Docker installed on our local machine and on the EC2 instance at both the places. Right from the very beginning, we are going to work with containers, right? So Docker is a must. So let us check what is Docker correctly installed or not, hyphen hyphen version. So we could see Docker version over here. Great. So Docker is installed over here. Now I think our first part is ready, but let us check the status of Docker. Sudo systemctl status Docker. So it is disabled. Now we'll enable it. So we are going to use start over here, start, and then we'll see. Okay, now we'll see the status again. Perfect. So Docker is started over here. Now let us see whether we can see the use the Docker commands over here. So it is saying that permission denied while trying to connect to Docker daemon socket at this location. Permission denied. So what this generally happens, Docker daemon runs as a root, and adding your user to the Docker group lets you run Docker without sudo, which is useful. So currently we can still see this process status by using sudo docker ps. But if we have to eliminate the use of sudo, what we have to do, we have to add this particular daemon. um, we have to add our user into this Docker group. So how we are going to do it? We are going to use sudo followed by user mod and then followed by flag a capital G. After that Docker, and what is my username? It is ec2 hyphen user. So I think this is done. Now we need to exit it so that it takes the effect, and then we need to SSH into our machine again. So we have logged into our machine. Let us see Docker PS. Perfect. So now we can see that. So our phase one is done. So we have completely, as discussed in the phase one, we have completely, launched an EC2 instance. We have installed Docker and we have prepared the server to run the container. Now, quickly, we'll go into the development part. So let us be the developer now and let us do some development on our local system. So we'll exit this EC2 instance, which we'll be using later. Now we are at desktop. Let me go into my directory, that is Newton's Apple, and further to, okay, let me see what all directories are there. Okay, let me go to YT DevOps projects over here, right? Now I'll quickly create a project mkdir followed by my project name, which is going to be FastAPI slash CI/CD. Okay, now let me go into FastAPI CI/CD. Perfect. Now I'll just create my simple fast API Python application. I am just going to write the code. I'm not going to install any dependencies over here, nor I'm going to create a virtual environment. Everything is going to be containerized. So what I'm going to do, I'm going to create a folder, a directory. So let me see, currently we don't have anything, mkdir, we'll get a directory name app, right? We'll go into app directory and then I'll create a file that is nano main.py. Okay, so this is where we write the code. So let me get the code for you guys. So this is the basic Python fast API code. It does nothing. So whenever this particular application is live, the server is running, so it prints a message CI/CD pipeline is running. That's all it does for now. So we'll save this particular command and we'll exit. Now what we are going to come a step outside, and then since we are going to Dockerize it, it is a requirement to create dependencies, right? So we'll create a requirement.txt file. So what are you going to do? We are going to write nano requirements, requi. Okay, let me check the spelling. Okay, requirements dot txt. Perfect. So what all requirement do we have? We have a fast API that is supposed to be installed. So what is this fast API? Fast API is a framework that we are using to build the API. So it provides the routes, it does request response handling, JSON serialization, validation, server logic, everything. So this is a must. Apart from that one, we need this UVCon. UV Con, right? So what is this UVCon? So UVCon is a web server. So Fast API does not run the application by itself. So instead, a server. So it also needs a server to actually, serve HTTP requests. So the server is UVCon. So UVCon handles starting the server, handling request, running async, and Fast API code to everything. So this is a must and a requirement. So now we are going to save this file. Control X, Y, we're going to come out. So requirement.txt is done. Perfect. Now we'll move down to third part. So we'll create a Docker file, because as I said, we are not going to run anything locally, install anything on our local system. Everything is going to be inside the container. So what are you going to do? We are going to do this Docker file. So nano Docker file is here, and then we must be having a Docker file over here, right? So we just need to copy this particular Docker file, and yes, I'll be sharing all the commands, at the end of this video also, inside a file, or maybe I'll pin it down in the comments so you all guys can check it from there. So this is there. Now let me give you a quick idea that what this particular Docker file does. So Docker file is set of instructions that while the container creation, Docker daemon will follow and it will create the image, right? So first what it'll do, it will, from the base Python runtime, it will install Python 3.10. So it will install Python inside the container, and then it will set the working directory inside the container as /app. Now it will install all the dependencies that we have mentioned inside the requirement.txt file using the run pip install container, and then I'll expose the port 8000. So since we are exposing port 8000, we also have to make sure in our EC2 instance that we have to add a network rule to allow traffic from port 8000 also. So we will do that, and then finally we'll run this command. This command is used to start the server, right? So this is what has been done. Now what we are going to do, we are going to save this and we are going to exit. Perfect. So what all things do we have now? We have got an app inside which there is mains.py file wherein we have written the fast API code. Then there is a Docker file, and then there is a requirement.txt. Now let us test this internally first. But before that, let me see, do we have Docker installed or not? Docker hyphen hyphen version. Okay, Docker is installed in my system, but you do not have to worry. Whatever system you are using, be it Windows, be it Linux, you can straight away go to Docker for, let's say, Mac, and then you will get this particular link. You can just install it for Mac Silicon or with Intel chip. If you are running on Windows, you can just type in here Docker for Windows. This is what you can do, and you will get the link for Docker to Windows. So you can just install it over here. The binaries will get installed and the Docker would also get installed. So once you have done the installation, once you will type Docker version, you would see here Docker version. Now the next step what you're going to do, so we have got the requirement.txt, we have created the Docker file. Let us create an image out of it. So what you're going to do, we are going to create an image. So what is the command for this? Docker then build hyphen T, and what is going to be the image name? It is going to be fast API container, fast API CI/CD app, CI/CD app. Let this be the name of the image. And where is the Docker file? It is in the current directory. So that's why I put up a dot. Now let's say what will happen. So I'm hoping it creates the image. Yes, since Docker is installed, it is, it has created the image. Now let us check whether the image has been created or not. So let me put Docker images. So I could see a image over here. So this is the previous image that I used to, create while testing. But yes, this is a new image that has been created. Let me see if there is an existing container running or not. Docker ps process status. So there is no container. Let me see Docker ps hyphen a, any container in a, yes, there is a container. Let us try to remove, even though if we don't remove, that's not a problem. So let me try Docker rm 153. Okay, I think it has been removed. Let us see Docker ps hyphen a. No, it's here. Now there is a Docker image. Okay, images. Docker images. So okay, this is there now. Let me delete. I think we created this particular image right away, right? Using the name app. Now what we are going to do? We are going to delete. Let us try delete. Even though if we don't delete, not a problem. Docker RMI then 040. Error response, no such demand. No problem. Let us keep that particular image. That's not a problem. So now what we are going to do? We are going to create a container out of the image. So we are going to use Docker run hyphen D, then hyphen P. What is our port name? Our port is 8000 on the container, 8000 on the host. And what is the name of the container over here? Fast API CI/CD container. And what is the image we are going to use? We are going to use Fast API CI/CD app. So the container has been created. Let us see Docker PS. Yes, the container has been created. It is up for 3 seconds. Now let us check, are we going to access the application or not? So let me close this Docker. It is going to be localhost. Port is 8000. See, CI/CD pipeline is working. So this is the exactly the same code that we have written. Do you see this code? CI/CD pipeline working. Now what are you going to do? So I think our phase 2 is also done. So we have created this particular application, and this application is working really well in a local environment. Now what are you going to do? We are going to move on to the phase 3. So what is our phase 3? So inside phase 3, we are going to do all the Git level configurations, and then we are going to push the code into our Git repository. So quickly we log into the Git. So let me log into GitHub. Okay, GitHub, login, sign into GitHub. If you don't have an account, no problem. You can just quickly create a account. I already have an account. So what I'll do, I'll just create a new repository. Okay. So I'll put down the name of the repository as Fast API. Okay. Fast API app. So this is the name that I think we should do. But before creating the repository, what we can do, we can just initialize. So what all changes we have done? We have done a lot of changes, but what we can do, we can just initialize the Git locally first so that it tracks the changes. So initialize an empty Git repository, that's not a problem. Now we'll see Git status. So it has seen all the 3 files over here. So what are you going to do? You're going to add it. Git add dot. Now we'll see what is the git status. So git status is this. Perfect. And we are going to commit this also. Now you must be having a question that we are committing nowhere. But wait. So we will just come down to that. So git commit hyphen m, and let's say initial commit, right? This has been committed. And if you see the status, nothing to commit over here. Now what we are going to do, we'll create this particular repository. So we have created a new repository named as Fast API app, and you have to make sure that there is a toggle button of README. So We are not supposed to, click this on. Why? Because, whenever we are creating a repository with this README option over here, so GitHub makes the first commit for you. So this means that local remote repository is no more empty. And now your local repository has also its own first commit that we have done just now on our local system. So when you run git, push origin main. So when you're pushing from local system to this git, it will emerge in a conflict. Why? Because your system knows that you have cloned an empty repository, and here using this README, GitHub has already made a commit. So there is this problem that we might come into, although it is resolvable, but still, let's not go into it. So let us keep all the default settings like this, and then we create a repository. Perfect. So the repository is created. Now what are you going to do? So now, right now, this repository has nothing over here. So what we'll do, we'll just push our entire thing into the repository that we have created. So we need to copy this particular URL over here, and now we'll be putting down the commands. No problem. I don't worry. I'll be sharing all the commands that I've used phase wise. I'll be pinning down in the comment. So here you have to use git, then branch, then hyphen m, and what is my branch? That is main. So I have got into the main branch now. Now what I'll do, I'll put git remote add origin followed by my this URL, right? So this is also there. Now what I'll do git push. So git push hyphen u origin. You have automatically, okay, to push the current branch upstream, use git push set upstream origin main. Okay, okay, main. So now it has been successfully pushed. Now let us check whether our code has already reached our repository or not. There it is. So we have got the app docker file requirement.txt. Perfect. So what we have done, we have used the version control, and we have, got the code from our local system to the remote repository, that is our GitHub repository. Now let us create the GitHub action workflow. So before I make you understand what is GitHub action workflow, it is nothing but a GitHub's automation engine. So we are going to write a YAML file in which there is a set of instructions, and there is also a condition that is set that whenever a code is pushed onto the main branch, it will trigger a series of events or the instructions that is written in that YAML file, and it will execute them in that manner. So quickly, what we are going to do, we are going to go inside here, and we are going to, like, let us see what all files do we have. Do we have a, okay, .git file is there. Now what we are going to do, we are going to create a file mkdir followed by -p, and then we are going to create a file named GitHub, and underneath we are going to create workflows, right? So this is the directory that we have created, and now I'll put I'll create a file inside it naming deploy.yaml, right? So what I'll do, I'll nano GitHub workflows deploy.yaml. So this gets my editor open. Now what you are going to do, I already have a script over here, which I'll give you an explanation in a minute. I'll just quickly copy and paste this. So this gets copied, and this gets pasted as well. So this is basically just a series on set of instructions. So what is the name of this particular workflow? It is the name is CI/CD pipeline, and on pushing onto the main branch, there are certain jobs that will be executed. So what are the jobs? So first it will check out the code, then it will log into the Docker Hub using the Docker username and password. So we have to remember that nowhere we can put down the username, password, secret, this kind of data into a code. So the best practice is to save them as a secret or environment variable and just use that variable over here, right? And once it logs into the Docker Hub, then it is going to build a image over here, build the image and then push the image into that Docker Hub. Why? Because this particular server or this particular operation is very short-lived. So once the image is created, the image is not going to get sustained. So what we are going to do, we create an image and then we take the credentials of Docker and we push that particular image into that Docker hub. And from Docker hub, EC2 instance will pull the image and then it will run a container and then we can access it, access the application using the public internet, right? So we'll just save it up and this is done. Perfect. So now what we are going to do, we are going to enter the phase 4. So phase 3 is also done. So what was our phase 3? So phase 3 was initialize Git, push code into the Git, done. Add Git action workflow and push it and to build, push and deploy. So we have already we have already created the script for GitHub Action. We have created the default repositories also. And now we are going to do our step 4, which is create a Docker Hub repository, add GitHub secrets and commit workflow and trigger the build, right? So let us go to Docker Hub. So you have to easily search Docker Hub on the portal and then you need to log in. So once you have logged in, so you can just create a, you can just easily create your, account over here. It will just only require your username and your password. So once you have logged into there, you have to go to repository section and you have to create a repository. So this is already a repository I have. What I'll do, I am going to uh, delete this repository initially so that we stay on the same page. So what is the repository name? The repository name is FastAPI application. So delete repository forever. So the repository is deleting. This may take a while. So we'll create a new repository meanwhile. So we'll put the repository name as Fast API app. I'm pretty sure that it might raise a error. Why? Because it will say that already a repository with this name exists. But let us see that whether it got deleted or not. So meanwhile, let us do some other configuration. So as I said, currently we accessed our application using the port 8000, right? But here we need to check under security. We have to check the rules. So whether port 8000 is allowed. So here you see that port 8000 is not allowed inside the inbound. So what we are going to do, we are going to go inside security groups and we are going to edit inbound rules and we are going to add a rule. It is going to be custom TCP only. The port what you are going to require is 8000 and from the source it should be anywhere from IPv4 and then we are going to save the rules. And let us check whether this repository has been deleted. So the repository has been deleted. We'll create a repository now and the name will be fast API dash app, fast API dash app, and then we create the repository. Perfect. So the repository has been created and it is followed by a username and followed by our repository name, right? Now, what we are going to do, we are going to go into this GitHub repository over here, and then we are going to make some environment variables and secrets over here. So we'll go into secrets and variables, and then we are going to do actions. Then we're going to do a new secret. So what is going to be the name of the secret? Docker underscore username. And what is the secret value? So my username was Ashish Bharti. Then we add a secret. Similarly, we are going to create a for passwords also. So it will be Docker underscore passwords. Password. Password. For now, it is Mendeleev at the rate 123, but I'm going to change it. So as soon as the video comes out, so I'll just put down the password over here. And then the third is going to be for my EC2 host, right? So what is the name of my EC2 host? So I'll just put down EC2 underscore host. And what is the name of my EC2 host? So it will take the public IP. So the rules have been created. We'll go down to the dashboard and I'll go down to my running instances. and this is my instance. So I'll open it up, and here is my public IP. So I've copied my public IP, and then I'll add the secret. Now you must have remembered that we always have this particular PEM file with which we are securely logging into our system. So that PEM file is required for us to log in. So similarly, on automation, this particular key will be required. So we'll be adding that as well. So we'll create the repository and we'll use the name as EC2 underscore SSH underscore key. And what is the value? So what we are going to do, we are going to cat. Let us see first, where are we? PWD, okay, one, two, three, three step back. So we're going to do cat dot dot one dot dot two dot dot three, and it will be FastAPI dot pem. So do you see this entire file right just before this ampersand sign? You need to copy this entire file. We need to copy this and we need to paste it over here. I need to add the secret. So this also gets created. Perfect. Now what we are going to do, I think this part is done, and we are going to go back to our terminal, and we are going to see git status now. Right now there is no action, and why this GitHub is in red color? Because we have created the workflows over here. So this workflows needs to be pushed down to Git as well. So we are going to do, we need to do git add. Now let us see git status. This is here. Now we'll do git add. So what are we going to do? We are going to commit git commit hyphen m, and what is the file over here? Add CI/CD workflow, right? CI/CD workflow is here. Okay, so these all our changes have been committed. Now if we see the status, everything has been committed. Now we'll push it. So we'll just use git push. So this has been pushed. Now let's see the actions. So do you see, as soon as the code got pushed, the GitHub senses, the GitHub workflow sense that there is a change in the main branch, and it has started performing the actions, right? So now it is going to work as per the script. So if we just look onto the script once again, so uh, it has sensed change on the main branch, and then it has started the job. So it is going to check out the code, what changes have been done, and it already has a Docker username, Docker password. So the workflow has been committed, and now it will create a image using the Docker file and the code whatever we have pushed in, and using that particular image, it is going to push that particular image to our Docker Hub. And from Docker Hub, EC2 instance will be pulling the image. And because see here we have already given, the host name as EC2 host with username EC2 user, then password, that PEM file we have already given. Then what is the script? Once EC2 instance is there, EC2 instance is launched, then it is going to pull the secret, that is the Docker username, and what is that particular repository name, that is FastAPI. So from that FastAPI app, this particular image will be pulled, and if there is an existing FastAPI container, that will get stopped or then removed, and using that particular image, it is going to run a container. So let us see what is the status of our Git. So build and deploy, it is status is success. Now let us check if you are doing HTTP, and we are going to use this public IP over here, followed by port is, you're right, 8000. Voila. So the application is working. Now let us do one more change, right? So let us quickly open this particular file. Let me open, nano, and what was this app and main.py, and let me add something over here, right? And let us see if Git senses it or not. Okay, so extra line added to check. I am just writing something, right? And now what we are going to do, we are going to save it. Control X, Y, exit. Now let us see Git status. Okay, this is Git has already tracked. Now what we're going to do, we are going to git add current. We're going to do git status again. Okay, it has tracked this. Now we're going to do git commit hyphen m, added a line as the output, added a line as the output. Okay, perfect. Now let us see. Okay, working tree clean. Now we'll do git push. So ideally what should happen? So the moment I push this particular commit to the remote repository, Git workflow should sense that particular change in my main branch and it should re-trigger the pipeline. So this is the expected behavior. Let us see what happens. So I have pushed and let's see what happens over here. We'll go to Git workflow and then we'll go to Git actions again. And do you see line as an output? So this particular line is my commit message. And let's see what is, so it is again trying to build and deploy. We'll wait for some time. So the behavior, ideal expected behavior is like currently I could see CI/CD pipeline running, and what changes we have made. So we have just added some random XYZ line over there. So I'm just waiting for this build to be completed. It might take 30-40 seconds to maybe a minute to get fully deployed. But yes, this is how the Git workflow work. So what we did, we tested the code on the local, but we nowhere installed the dependencies. Each and every time we were working inside the container. So, everyone, I just hope that you guys have a lot of association with the containers right from the very beginning, so that your hands are very free when you're working with containers, when you're working with various DevOps tools, working with the CI/CD pipeline, or maybe, working a lot of Linux commands. So then you'll have a lot of confidence. And, that's how you will master this entire, DevOps infrastructure, right? So since it has been already successfully deployed, let us check what is the output now. So yes, extra line added to check. Bingo, bang on. So we have done this, and this brings us to the end of the project. So today we took a simple fast API application and then turned it into fully automated, maybe production grade CI/CD pipeline using GitHub Actions, Docker Hub, and AWS EC2. Right? So what we did, from writing and containerizing the application to pushing our code into the GitHub repository. So this is what we have done. Then, building and deploying new versions automatically, which went through exact same workflow that is used by real DevOps, teams in the real companies. And you know what was the best part? Now, every time you update the code and push it into the GitHub, your application self-deploys. No manual steps, no SSH, no downtime, no room for human error. So that's the best part. So this is the true power of DevOps. I mean, I have to say, automation, reliability, speed. So that is why everybody wants to move to DevOps. And yes, if you followed along, congratulations, you just build a complete CI/CD pipeline from scratch, and make sure to experiment, break things, fix them, and continue learning, because the more your hands are messier, the greater skill that you will be acquiring. So thank you so much for watching, everyone. And if you found this helpful, don't forget to like, share, and subscribe. And yes, I'll see you in the next project. So where we'll take DevOps skills to the next level. Thank you everyone for watching.